Hi everyone. We're going to describe vectors from x and y components. We're going to see in a minute that we're going to be given the x and y components of a vector, and we have to describe the resultant vector. We're going to round the magnitudes to the nearest tenth and directions to the nearest degree. So to get our magnitude, remember that's like our hypotenuse. We're going to use the Pythagorean theorem, and we're going to use this. You need your calculator ready. So you need to pause that and get your calculator. And to get the directions to the nearest degree, we're going to use the tan because we're going to have already our y and x component. So the first example we have is our x component is 5 meters. Our y component is 7 meters. So I'm going to draw the resultant vector here. Okay, that's going to be my C part. And my angle that we're looking for goes here. Make sure your calculator's in degrees before we start this. And basically what we're going to do is find C. C equals the square root of a squared plus b squared. And when you get that, you should get, when you round it to the nearest tenth, 8.6 meters. So we're going to get 8.6 meters. And that goes here. Now we need our angle here. So we're going to use tan. We could use sine or cosine, but we want to use the given. Because what if we had made a mistake when we did this? Then you have basically two mistakes. So we want to use what is giving. So we're going to do tan of theta equals y over x. And to get that value, you take tan inverse of 7 over 5. And when you put that in the calculator, you should get 54. We're going to round down, so you'll get 54.46, so we're going to round it down to 54 degrees. So this is 54 degrees. And now you have to describe it. So the way we describe that is we're going to say that it's 8.6 meters at 54 degrees north of west. If you haven't seen my previous video on how to write this, basically this is the main place, the direction, and then we're north of west. Okay? So watch one of my first videos on vectors, and there's a quick video on that. Okay, let's try another one. We have our x and y components here, and we have to find the resultant vector. So basically that's our C. So C equals the square root of 14 squared plus 11 squared. You put that in the calculator, and you should get 30.4. Okay. So, no, I think this is 17.8, sorry. I have this written down. I already did this so I can make the video faster. So this is going to be 17.8 meters. 17.8 meters. Now we're looking for this angle here. So tan of theta equals 14 over 11. So theta equals tan inverse of 14 over 11. And you should get 52 degrees. So our answer is going to be 17.8 meters at 52 degrees north of east. Okay, the next one, do the same thing. I'm going to go a little faster. I draw the resultant vector here, and I do C equals the square root of 15 squared, I don't care about the order here, plus 7 squared, and that's going to give me 16.6 meters. And now I need this angle, so I do tan of theta equals y over x, which is 15 over 7. So theta equals tan inverse of 15 over 7. So theta equals 65 degrees, and the way you write this is 16.5 meters. Is it 16.6? Okay, 16.6 meters at 65 degrees south of west. And that's how you describe a vector. This is your magnitude. This is your direction. Okay, here we go. I'm going to draw the resultant vector here. So C equals the square root of 23 squared plus 12 squared. And that's going to give us 25.9 meters. And then tan theta is going to equal tan inverse. My y portion is 23. My x portion is 12. And so theta is going to equal 62 degrees. That's 62. So the way you write this is 25.9 meters at 62 degrees south of west. Okay, the next one, I'm going to go in a little faster. So go ahead and pause and all that good stuff. 25C equals the square root of 25 squared plus 32 squared. Put that in the calculator, and you should get 40.6. And then we're going to call that meters. 40.6 meters. Now we're looking for this angle. So theta equals tan inverse of y, which is 32 over x. Tan inverse, sorry about that. And you should get 52 degrees. And the way we write this is 40.6 meters at 52 degrees. I didn't put this north, south, east, west. So it's going to be north of west. Okay, now I have this one. Draw this. C. This is my magnitude. It's going to be 10 squared plus square root of 10 squared plus 2 squared. So this is going to equal 10.2 meters. And then our angle here is going to be theta equals tan inverse of y over our x. And that's going to equal 11 degrees. So we write this as 10.2 meters at 11 degrees. And I didn't put my north, south, east. So it's going to be south of east. Anyway, west, because we're here. So this is the main one. And you do south of that. South of east. The last one we have is in the third quadrant here. So C equals the square root of 4 squared plus 1 squared. And that's going to equal 4.1 meters. I want this angle here. So theta equals tan inverse of y, which is my vertical, 4 over 1, so just be 4. And that's going to equal 76 degrees. And this is north, south, east, west. So we're at south of west. So we're going to write 4.1 meters at 76 degrees south of west. West is the main one, and south is just opposed to, it's not north of. It's just telling you what quadrant we're in, basically. That's all. The next one we're going to do is use actual problem solving involving vectors with story problems. Have a nice day.